This is my Unit 4 bonus video, and we're going to do Pascal's triangle. Question 1. 3a plus 2b to the power of 5. We're going to use Pascal's triangle to solve binomial expansions of binomials. To build the triangle, we start with 1 at the top, then continue placing numbers below it in a triangular pattern. Each row begins with 1 and ends with 1. Begins with 1 and ends with 1. Each row has an increase of one number to the amount of number in the previous row. This row has 2 numbers in it, and this row has 3 numbers, the next row will have 4 numbers, the next row will have 5 numbers, the next row will have 6 numbers, and so on. In order to get, for example, this middle number here, you add the numbers on above it, directly above it, these 2 numbers. So 1 plus 1 equals 2. These numbers also represent coefficients of binomials to the power of, this one represents binomials to the power of, coefficients to the binomials to the power of 0. This row represents coefficients of binomials to the power of 1. This row represents coefficients of binomials to the power of 2. This row represents coefficients of binomials to the power of 3. This row represents coefficients of binomials to the power of 4. This row represents coefficients of binomials to the power of 5. In this question, we want to find binomials to the power of 5, so we use these coefficients: 1, 5, 10, 10, 5, 1. We place these coefficients: 1, 5, 10, 10, 5, 1. We start the first term with the highest power, so the highest power would have to be 5. So 3a to the power of 5. After each coefficient, the first term's highest power is decreased by 1. So 3a to the power of 5, 3a to the power of 4, 3a to the power of 3, 3a to the power of 2, 3a to the power of 1, 3a to the power of 0. And the second term with the lowest power of 0 starts with the lowest power of 0. After each coefficient, the second term's lowest power increases by 1. So 2b to the power of 0, 2b to the power of 1, 2b to the power of 2, 2b to the power of 3, 2b to the power of 4, 2b to the power of 5. 3a, now we insert the exponents into the terms. So 3a to the power of 5 is 243a to the power of 5. 2b to the power of 0 is 1. 3a to the power of 4 is 81a to the power of 4. 2b to the power of 1 is 2b. 3a to the power of 3 is 27a3. 2b to the power of 2 is 4b2. 4b to the power of 2. 3a to the power of 2 is 9a to the power of 2. 2b to the power of 3 is 8b to the power of 3. And 3a to the power of 1 is 3a. And 2b to the power of 4 is 16b to the power of 4. 3a to the power of 0 is 1. 2b to the power of 5 is 32b to the power of 5. When you multiply these numbers, you would have 1 times 243a to the power of 5 times 1 equals 243a times 5, a to the power of 5, sorry. And plus 5 times 81a to the power of 4 times 2b equals 810a to the power of 4b, plus 10 times 27 times 4 is 1080, and a3b2. 9 times 8 times 10 is 720, a2b3. And 5 times 3 times 16 equals 240. A1, B4, so AB4. And 1 times 1 times 32b to the power 5 equals 32b to the power 5. So 243a to the power 5 plus 810a to the power 4b plus 1080 a to the power 3 b to the power 2 plus 720 a to the power 2 b to the power 3 plus 240 a b to the power 4 plus 32b to the power 5 is the binomial expansion of 3a plus 2b to the power 5 using Pascal's triangle.